Welcome to lesson 9. Thanks for coming. This is what we're going to cover today. We're going to do a few more things on lists that we didn't cover last week. Just wrapping up some of the techniques that you need to be aware of when it comes to using lists. We're going to learn about string manipulation. Have I been over what strings are before?
Yeah.
Okay, strings are a collection of characters. So you can think of it as a piece of string with some beads on, where every bead is a single character, A, B, C, 1, 2, 3, and if you put them together you get words. Where we as humans read words as components of a sentence that are broken up by space, a computer doesn't care about the space. It sees the space exactly the same as it sees A, B, C, or 1, 2, 3. So everything put together is for it one long string. But we'll cover how we're going to work with those. We're going to do an exercise called vowel counting, which is a string manipulation exercise. We're going to do something called fixing spelling, and we're also going to do something on how to spell your name. I'm sure you know how to spell your name by now, but we're going to get the computer to do it for you. And then we are going to cover something called encryption and decryption. Have you heard of that before?
Yeah, I have heard of it.
Okay, alright. Any idea what this picture in the top right hand corner is?
It's a typewriter.
Nope.
It's not a typewriter.
Well, that would be also correct, but not an answer.
A computer.
Kind of. Okay. Back in World War II, obviously the two sides were fighting each other and they needed to send messages so that the other side couldn't get it. Okay. This is what they called an enigma machine. It was used by the Germans to encrypt their messages that they would send off to the submarines, and on their side they would have a similar kind of machine and they would be able to decrypt them there. One of the big achievements of winning the Second World War was the fact that they got to encrypt or decrypt the messages, which is a whole story in itself, but well worth looking into if you're interested in it. Okay, this is quite a long lesson. We might not get through everything. I was trying to squash in everything before your exam started, but if we don't get through it, then I think we've still got one scheduled for the end of November after your exams.
Is this the last one?
Well, this slide is, Okay. If you want, we can try doing some filler in lessons before you go away where we just do exercises or theory, but I'll leave that up to you if you have time and that kind of stuff. But if we don't finish what we're going to do today, then we'll finish it the lesson after your exams. So we're going to look at the repeat until and forever blocks. We've already used some of them a little bit, but we're going to cover them formally. We're going to write a program to do times tables. I know it's a bit late in your career, but we're going to give it a shot anyway.
I don't know them in any case, so it's fine.
Oh no, don't tell me that. Don't tell me that. We're going to do the addition test, which is another example program. We're going to learn how to stop a script, which is something we haven't used much, but it is useful in some cases. We're going to learn about user input validation. Does that make any sense to you?
Yeah.
What is it?
And it checks that what you put in is correct.
Yes. Okay. So when you start off writing computer programs, you blindly believe that the people who are going to use your programs will be very nice people and only do what you ask them to do. That's not reality at all. So whatever they give you, you always have to check and make sure it's the right thing. It's not so much a problem with Scratch, because Scratch, as I've said before, is very forgiving. But with other normal or traditional languages, if you ask for a number and you put in a letter, your program will crash if you don't do your validation. And then we're going to have a look at exploring counters. Okay, this little picture in the bottom right is a counter thing. You might have seen it at school for counting laps and that kind of stuff. Counters are very important when it comes to computers. So yeah, so let's jump right in. Okay, last week we covered lists. Okay, lists were variables which could contain multiple values. They had an index, which was the number indicating their position in the list, but the value at that index could be pretty much anything, just like a variable. Okay, we looked at a block called the contains block last week, and this is an example of just a simple way of figuring out if something is already in a list. Okay, so we have a if then else block surrounding everything. The condition in the if then else block is days list contains Friday. If it does contain Friday, then we say got it, Friday is in the list, else we say sorry, Friday is not in the list. This is a very odd example, but the reason we do this kind of stuff is in programs we are always building up lists, and one of the important things is to make sure we don't have duplicates. Okay, and this is basically how you do it. It's very convenient that there's the contains block, because if you didn't have the contains block, what would you have to do?
Search through them.
Exactly. So you would have to iterate through each item in the list. Well, technically each item. In practice you would iterate until you found it, and then you would stop iterating through the list. This contains block effectively does that for you, so you don't have to worry about it. Okay. Now we are going to look at another example. Okay, I'm not making you type these out because we've got a lot of exercises that you will get to do. So I'm just going to work through them with you if that's okay. So this is a function or custom block which you've created called search list. It takes one parameter or input called target. And our target is we are trying to find something in this list, and the value that we want to know is what is the index or the number for that item. Okay. As far as I know, Scratch doesn't give you, actually it does give you, no, it doesn't give you a function to get out the item. So this is where we are going to do that iterating that we said we would have to do if we didn't have a contains block. Okay. Now we need to keep track of where we are so that we know what the number is. So we've created a variable called pos, short for position, and we initialize it, meaning we set it to an initial value of 1. Then we do a repeat loop for the number of items in our list of fruit. So this repeat loop is going to go for length of fruit, which we can see as 5 at the bottom here. Alright, on each iteration, each instance of the loop, we do a check, a if-then check, and we check if the item at position, whatever our position is, of fruit is equal to our target. Remember, target will be orange, apple, banana, peach, or mango. Okay. If it is, then we stop the script. Okay. How's that going to help us if we stop then and there? Okay. We've got our variable, pos. Okay. Remember, when you create a variable, it automatically puts a variable monitor for you on the screen, and you'll be able to see what the value is when it stops.
So you can see what position it is in the list.
Okay. If the item that we're looking at is not equal to target, then we change pos by 1. Okay, which is effectively incrementing it by 1. Take its current value and add 1 to it. So we start off at 1, we go to 2, we go to 3, we go to 4, we go to 5. Okay, so after the end of every iteration we increment it by 1. Okay, what happens if our item that we're looking for is mango? Okay.
Yeah, it will run 5 times.
It will run 5 times, but what will the value of pos be after that?
5?
Nope.
6.
6. So if we need to use that value afterwards, we need to take 1 away.
For all of them or just mango?
It'll be for all of them. Okay, it will be for all of them. I just used mango because that would have it run through all of them. But in each case, you would subtract 1 at the beginning. Okay. What could we do to not have to do this step here?
Set pos to 0.
Yes, we would initialize it at 0 and only increment it after that. The problem with that is, if we start off with 0 and we say item 0, what's going to happen? There is no 0. Okay, so we would have to change our pos by 1 and move that to the top here. Okay, just above the if instead of after the if. Okay, but this is a general kind of algorithm that you will use often when you're searching for things in lists. Again, in more commercial programming languages, they do have built-in functions which will return you the index for an item in a list. Okay, let's get on to strings. Okay, as I said, strings are a list of characters. Okay, I say characters and not letters because as far as a computer is concerned, a number and a space and a question mark and a full stop are all characters. Okay, you can use numbers as pure numbers, mathematical numbers, but you can also use them as things in a sentence. I've got 6 apples, or my car has 4 wheels, or something like that. So just remember that duality. So if we look at a string, okay, we would call it a sentence, and in this sentence it's got 4 words. This is a string, but there are 3 spaces separating those words. When it comes to computers, they see the individual letters, THIS, and the space as equivalent. Okay, there's a thing called ASCII. Have you ever heard of that? Okay, ASCII stands for American Standard Code for Information Interchange. Okay, it's been around most probably since the 50s or 60s. It's basically a table of all the what they call printable characters. So the reason they say printable is because when you started off with computers, way back in Noah's Ark time, they started off with little lights. Okay, then that was the only thing that the operator could see to see what was going on in the computer. Then they had a thing called a teletype, which is literally, have you ever seen a dot matrix printer? No. Do you know what a dot matrix printer is?
I have heard one.
Okay. So currently these days we have what we call laser printers and bubble jet printers. Before those we had dot matrix printers, and before that they were teletype printers. It literally had a chain with all the letters on it, much like a typewriter, and it would move this chain up and down to spell out things. So that was print out. They would print out the output from the computer onto paper. So that's why they call ASCII character set the printable character set. It's something you can put on paper, and after paper obviously came the screen, so something you can display on screen. There are lots of characters that are not printable. Okay, there's a beep character. You can't print a beep, it's a sound. There's the null character, which is the nothing character. You can't put nothing on a piece of paper or screen because no one will be able to see it was there. So we've got our ASCII, which is a standard table, and I think it has uppercase and lowercase because those are different. They look different, so they have to be different. And I think A is 65, B is 66, and so on. I think enter is 13 or 10 or something like that. Enter would be an example of a non-printable character. Okay. So we've got a standard character set. After ASCII there was something else they brought out, I think it was in the 90s, called Unicode. Have you ever heard of Unicode? Okay, where ASCII has at most 256 different characters, Unicode has got a couple of 100,000. The reason they brought out Unicode is it covers character sets from all over the world. So if you're doing Russian or
So
Chinese...
it's kind of like what the thing you get when you're like in Word and you want to insert characters.
Yes, that kind of stuff. There are keyboard shortcuts to create Unicode characters. You'll also see it often in, I don't know if you're on Twitter at all, you'll see in the username field, people do funny things. There's that little thing with the flipping of the chair and or the table, and people do little squiggly things or put their letters upside down. They are using Unicode characters to get that. Okay, and Unicode covers just about anything on the planet. It's English, Chinese, Japanese, Sanskrit, Russian, whatever you want, plus all your emojis as well. All your emojis come from Unicode as well, and they regularly update Unicode to include more of the emojis. Anyway, big side quest there. So we have got a string of characters. So if we look at the bottom here, we've got the name Karen, and each character has an index, much like a list. So K is 1, 2, A is 2, R is 3, and so on, and N is 5. So we can set our variable to the value Karen, which is a string, and then we can go and pull out the letters in that string using the index. Okay, and we've also got the length. Okay, so exactly the same way we had a list where we can get specific items out of a list and get the length of the list, we can do exactly the same for strings. Okay, and this again is something that you're going to do often when you do programming. We've already looked at another block in previous lesson called the join block, okay, where we took 2 or 3 words and we joined them together. You do the same thing when you give feedback to a user. We'll have a look in our times table example later, where you have to say 2 times 3 equals 6. You have to build that up every time, because if you're doing the 3 times table, that'll stay the same, but your multiply and your answer will change every time. Alright, so again, just going to walk through this example. We'll do some of the other exercises on hand, or by hand a bit later. So we've got a standard program here. We start up at the top with when green flag clicked, and we ask the user to enter a sentence. Whatever, doesn't matter what it is. And then we have 2 variables, or we have 3 actually. We've got vowel count, position, and ch for character, ch. So we initialize our variables, set vowel count to 0, set position to 1, and what we are trying to do is count how many vowels are in the sentence. Okay, unless it's some weird obscure language, there should be at least 1 vowel. So we set our position to 1, and then we do a repeat loop for the length of our answer. So we're going to step through each and every character in the sentence that they gave us, and then we're going to set our character to the letter at pos, which starts off at 1, of our answer. So we're going to march through each character in the sentence, and then we have to do a check to see if they are vowels. So we do a check for A, we do a check for E, I, O, and U. Our 5 vowels. If the character that we're currently on is any of those, then we increment our vowel count by 1. So we increase its value. We've used an OR here in between, because it obviously can't be all of those values at once, but it has to be at least one of them. And remember back to our AND, OR, and NOT that we did last week, OR will give us the 1 as long as any one of the input values is 1. If we change them to AND, all of them have to be 1. Okay. Alright, so we do our repeat, we get our character, we check if it's the valid character that we're looking for, we increment our vowel count if it is, and then we increment our position.
Would this, would your entire sentence need to be in caps for this too?
That's something I'm going to get you to check just now when we do an example. Most programming languages are what we call case sensitive, okay, which is a royal pain in the butt, because it can go even as far as a whole database can be case sensitive. Yes, so if you type in Bob and you don't use the right uppercase and lowercase values, and you put in a different version of Bob, it will not match. It'll see it as 2 distinct different values. Most programming languages, not most, well, a lot of them, are also case sensitive in the language itself. Okay, so what they call keywords, so for instance your set, your ask, your repeat, they are usually not case sensitive, but your editor will correct you anyway. But if you go and create variables, okay, and you create a variable called pos, all lowercase, and you create another one all uppercase, those will be seen as 2 different variables. Okay. Scratch, I think, doesn't really care about case, so it's quite what we call case insensitive. So if you put a big A or small a in, it doesn't mind, it treats them as the same. But we can check that just now when we do some of our examples. So we've looped through all the characters in our sentence, we've counted how many were vowels, and then at the end we report back to the user and we say your sentence has vowel count vowels. Okay, and this is the last line here, is the kind of thing I was mentioning earlier, where you have to put your characters and letters and sentences together to show stuff to the user. In traditional programming languages, doing this is a lot easier. It gets quite clumsy in Scratch, but that's to keep it simple. Alright, so if we have a look at stepping it up a bit, we are going to insert one string into another string. Okay, so this is leading on to our spelling, fix the spelling example. So we have our 3 input variables here, and our output. Okay, so our input variable we call string in is help. We're going to add a string called w and at character position 3, and then our output will be help. Okay, so we'll go to position 3 and put the w in and bump the L and the P up. Okay, so there you can see it's done an insert. Okay, the way we're going to do it is going to teach you the concept in Python or C# or Java. There are functions that will help you to do this, but you have to know how those functions work to be an effective computer programmer. Okay, this is an example on your flash drive if you want to look at it. No, that's fine. It's called fixmyspelling.sp2, so we'll just walk through it again. Alright, so we've got a function that we define at the top, or a custom block called insert, and it has a string add, it has an into, string in, at position, chart position. Okay, so these ones in the light blue blobs are the actual variables. The ones in front are just labels to help you figure out what to do. So this actually reads quite nicely as a sentence. Insert string add into string in at position, chart position. You couldn't do the same thing in a normal programming language because they don't allow you to put labels in between your parameters. But for Scratch it helps quite a bit to see what's going on. So when we enter our function, we create a set of variable called string out to blank. Okay, so that's how you empty your variable of any value, and we set our position to 1. Then we're going to repeat the length of our string in, so the help, that's our string in, help over there, and we are going to set character to length position of string. So we're going to get the first character, which will be H, okay, and then we're going to say if position equals char pos, so the position where we must insert it, then we say string out join string out plus string add. Does that make sense to you? Okay. Then we set string out to join string out in character. Okay, and then we change our position by 1. So we basically get a letter, we check if we at the position that we want, we insert the new thing, and then we put our characters in front of it, and we carry on building up our string out one character at a time. Does that make sense? Alright. Okay, so this is the rest of the program. So you can see sort of in the middle we've got our insert block, which is what we've just covered over here. This is how we're going to use it. Okay, so we've got a variable called ABCD, basically all the letters of the alphabet. Then we've got our in word, okay, and we're going to pick a random from a word list. I think, yeah, if you have a look in the example on your flash drive, you'll see there is a list defined called word list. Then we're going to set a random character. We're going to pick a random character between 1 and 26, because there are 26 letters in the alphabet, from our alpha list here. So we're going to pick any one of these characters out of here and use that as our random character. Then we're going to pick a random position anywhere between 1 and length of our word that we've chosen. So we can't put a fixed value in here because we don't know which word we've chosen, and they're not all the same length. But we do know we've got a function which will give us the length of a word that we've chosen. So whatever word we pulled out of our word list, we get the length and use that as the upper boundary on our random position. Then we call our function with our random character, our word, and our random position. And then we go into forever loop. Okay. Now forever loops don't usually stop. But we do have a stop command, and we can use that to stop the forever loop. And what we're going to do is we're going to ask the user to enter the correct spelling for the jumbled up word that we've given. Okay, so they type in an answer, hit enter, it gets stored in the answer variable, and then we compare it to the input word, the random word we chose out of our list. If they are equal, then we say good job, and we stop because it's correct. If not, then we say sorry, not it, try again, and then the loop continues. So this will carry on until they type in the correct word. Does that make sense?
Yeah.
Okay. Alright, so now you have an exercise to complete. Okay, using the blocks that we've covered so far, you're going to ask the user to enter a name, store it in an answer, then you're going to loop through it character by character and get the cat to say your name.
Where were all of those blocks?
Which one? The string manipulation,
yeah.
at the bottom there, yeah.
Do I need to create a variable?
Yes. Technically no, but you can use a variable if you want to. It would make it a little bit more readable. Okay, I'm going to do it on my side and we can compare notes. See how far we get.
Got it.
Is it working? Oh, well done. Well done. Okay, let me just finish it on this side as well.
I'm just not sure if I had the first character. And then I can use the stop thing. After I do anything afterwards.
Yeah. If your program terminates naturally, then you don't need to use the stop. Okay, so you ask for the name, you set a position to 0, that's going to be our counter, to loop through each of the letters, and then we are going to have to get that letter. So we're going to say letter of your answer. Oops. Of your answer at your position, and then obviously you have to increment your position by 1. So let's say Bob, B-O-B. Okay, pretty simple example. Alright. Okay, so this is just a solution. I'm not going to go through it because we managed to do it quite easily. Okay, now we're going to do something called the secret encoder. So we are basically going to pretend we're spies during wartime. We've got a super important message we need to get back to HQ, and we need to encode it, making sure that no one can intercept it along the way and change it. Okay. Alright, so the user must indicate if they want to encode or decode a sentence. Obviously the one is the opposite of the other one. Okay, but that is not true for all encryption. Okay, you get symmetrical and asymmetrical encryption. Okay, symmetrical is the traditional encryption. That is where you have a way of taking your input and mapping it directly to your output. Okay, it usually for more advanced algorithms uses what they call a key, which is kind of like your password, to do the encryption either way. Then you get what they call asymmetrical encryption, and that is something what they will generally refer to as public key encryption. Have you ever heard of something like that? Okay. That is used a lot in the internet these days, where you're doing your secure internet banking. It puts a little lock up, and you click on it, and it'll say this is encrypted by TLS 1.1, that kind of stuff. That uses a certificate, and that certificate uses a thing called what does it use? It's just gone right out of my head. That'll come to me, but it basically boils down to using prime numbers, which are quite important when it comes to encryption. The original PKI encryption was using prime numbers, but more recently, and when I say recently, the last 20 years or so, they've switched to another thing called elliptic curve cryptography, which is also quite cool. Anyway, we're not getting that fancy at all. Okay, we are doing a simple, what they call a substitution cipher. So you have your normal alphabet, if you look at the picture at the bottom, A through Z, okay, and then you map that to a different alphabet. So A becomes Q, B becomes W, C becomes E. So our grey fox has arrived, changes to UKQN, YQB, etc. Why do you think this is a very poor?
Because it's very easy to figure out.
Why is it easy to figure out?
Because it's the keyboard. The letters of the keyboard substituted for
Yeah.
the dot order.
Yeah, but normal, all these other higher forms of encryption I've talked about, they also spit out gobbledygook letters. Why do you think it's easy? Come, you're doing stats. Tell me. Let your stats synapses kick in.
Everyone probably uses it.
No. Come, probabilities. Tell me about probabilities. What's the most common letter used in the English language?
Vowels.
Which one?
A.
E. E. So all you need to go and look for is the most common letter used in your encrypted text, and you'll know that is E. So that's already not one character off that you need to figure out. Then you go and look for something that's common, like A house, a tree, a car. It'll be a single letter, so we'll know that's most probably an A. Then we look at two-letter words, is, in, on, we can map that. And so you break it down, and eventually you can work out what the letters map to. Okay, so not the best one. More advanced encryptions do what they call chaining. Okay, so instead of mapping one character to another character, they'll take 2 or 3 groups of characters and map them to 2 or 3 groups of characters. Okay. Again, we're not getting fancy, just pointing out that this isn't the encryption you want to use when you send state secrets anywhere. Okay. So we're going to ask them if they want to encrypt or decrypt. We want to ask them to type in their sentence, so much like you typed in your name in the previous exercise. And then the program must give the encoded or decoded equivalent. Okay. And let's see how good you are at Spycraft. Have you heard of Alan Turing? Okay. He was a very brilliant English mathematician who also helped out in World War II. He came up with a thing called the Turing test, which they basically use to figure out how far we are down the line with artificial intelligence. And the basic premise there is that if you can have a conversation with a computer, and at the moment the conversation is generally a typed conversation, because they obviously don't speak and hear that well these days. If you can have a conversation with them and not know that you're talking to a computer, so basically the computer is able to fool you, then it's a sign of how far we are down the AI path. They've got things to go pretty far and pretty well. but they're not 100% there yet.
How many letters in the alphabet?
26 on a good day.
Okay.
You are still doing English, eh?
Yeah.
Yeah. Okay. Anyway, so he worked in Second World War on decrypting the Enigma machine that I spoke of earlier. He was part of a team at a place called Bletchley Park, and they've actually made a movie recently about him. So if you want to go watch it, that could be quite interesting. Yeah. The movie's not 100% historically accurate for movie reasons.
Yeah.
But yeah. The one caveat with your encryption that you're using now is that you can only use each letter once. So you can't have two input letters mapping to the same output letter. And why would that be? So if you had A and B both mapping to Z, that's great when you want to encrypt. What do you do when you decrypt?
Yeah, it's not gonna work.
It's not reversible.
Yeah.
Okay, because you'll end up with a Z. Now must I change that back to an A or change it back to a B? So just make sure on your bottom list that you only use each letter once in a different order to the normal order, but only once. It was actually quite funny. Up until the Second World War, when it came to cracking encryption, they didn't believe that mathematicians should be involved in the process.
So I don't need this stuff.
No, you don't, yeah. Because it's a two-valued answer, so if it's not the one value, it's the other.
Okay. Must then type in their sentence.
Type in a sentence.
Do I need to store this answer?
Well, there's two questions. The first question is, do you want to encode or decode? And the second question is, what do you want to encode or decode? Okay, the first one, I would actually type in the value first. So what is the value? And then ask them, do they want to encode or decode?
The sentence.
Yes, so store the sentence, because that's what you're going to work on. And the question is just a throwaway question to get you started on one of the two paths.
Or should I store it in a list?
Store what in a list?
The sentence. Can I do that?
You can if you want to. That just means you'll have to do a loop to break each letter out.
Let's see.
Okay, so I'm going to start on my side.
Am I getting there? Am I on the right path?
You are on the right path.
Yeah.
Don't know if you're going to get there, but you're on the right path. Okay, so
with this being centered in there. For some reason it drifted.
Yeah, there are a few bugs in the Scratch editor still.
I'm just changing the whole list of QWERTY to A.
Oops.
Oh no, not all of it. Just the first 10 characters.
Okay. Okay, have you got anything working yet?
No.
Okay, so when green flag clicked, we've got clear text, which is your normal alphabet, and then we're going to have encrypted text, which is going to be extremely original. Z, Y, X, W, V, U.
So it's not really going to work with the list.
You can use lists.
Yeah. But it's not as easy.
It's not as easy, and it is actually ironically a bit slower as well. You'll see if you complete your program, you'll see it actually running through the list each time. maybe it's only if you leave your variable monitor on the stage, but I've found doing it before that it's easier just to work with a single string of text each time. So there's ZYX, Okay. All right. Okay. Check if my garden is done.
Sure.
So you can encrypt here if you like, and then I'll get back to it when I'm back. Okay, so you're all done.
I'm trying to figure out what code I started with.
Okay.
Oh, I'm trying my best.
All right. Well, let me put your mind at ease. There is no one right way to do it. You can do it many different ways. And programming is an iterative thing. So you'll do a little bit, give it a shot. If it doesn't work, throw it away, do something else. And you build on it step by step. I also find when doing the programming to do a little bit, run it, see that it works the way you expect it to. Add a little bit more, run it, see that it still works. Because you can sometimes change one line and it can break everything. Okay. So, do you want me to leave you there or give you a rundown of what I've done so far? Or check what you've done? Okay.
Stuck when it gets to. Okay, the sentence beginning.
Okay.
I need the pause variable.
You are going to need a pause variable because you're going to have to step through your characters in your sentence. You might actually need two pause variables.
How do you like equate the letter that's in your sentence to the one that's in the encrypted
So
or decrypted
we are going to
text?
have we're going to have two pause variables. The first one is to step through every letter in your sentence that the user typed in. The second one is going to be to step through our clear text and our encrypted text strings, and they will be independent. because for your sentence you will go through every character in the sentence. For your encryption and decryption, you'll only go as far as you need to until you find the letter that you're looking for. So yeah, so that's
So you do something like if the letter in your sentence is equal to the letter in
your encrypted or decrypted. Yes.
Then
you basically
change it from this to this.
Yes. So you need an output. You'll see I've created an output variable, and that's where you're going to put your encrypted text or decrypted text into. So you've got your input, your sentence in your case.
So then you'd store in output.
Yes, you need to store it in output. Okay. Okay, so input length. I'm going to do this again. Okay, and I'll admit I'm being very lazy here. I should make some nice custom blocks to make this all work together. But from a point of time, we'll just throw everything in one long. Okay.
How do you set it like the first letter of the output and then the second letter of the output?
Well, that's what I'm doing here. So we're busy going through every letter of the input. Then we check if we're doing an encode or a decode. The only difference there is which do you choose as your input and which is your output. So if we do encode equals 1, so we are encoding, and we go through the length of our clear text, and we check.
Yeah, I've done repeat length of.
Yeah. Then we have to do a check to see if letter in pause, which is our input of input, equals letter position 2 of our clear text. Then
Not that much.
Say set output equal to equal to output plus letter position 2 of encrypted text. Okay. Does that make sense?
Yeah, I don't have pos 2. What's pos 2 for?
Okay, so remember I said we have two counters. The first one is to go through every letter in our sentence. The second is to go through every letter in our alphabet. Okay. Now technically you could say repeat 26 because you know there are 26 letters, but you do need a counter to know at which point you hit the letter you were looking for. Okay. And we need
This is a pretty complicated program. Yeah.
I thought you'd have it done in 5 minutes.
Did you really?
Yes.
Sorry.
That's
But I
okay.
don't. Neither do you, so it's fine.
True. Okay, so we need to increment our position 2 as well. Repeat, length of clear text. So change position 2 by 1 as well. Duplicate. Okay. So that is going to be length of encrypted text equals position 2 of encrypted text and clear text. So that's the difference between encryption and decryption. Okay.
Yeah, I think I'm just going to stick with the encryption for now.
Okay, that's fine. Alright, so let's see what you've done. If answer equals encode, then we're going to repeat length of sentence, correct. If letter position of sentence equals letter, now that pause needs to be your pause 2 of clear text, because you can't compare your sentence to your encrypting thing. Alright, then set output equal to join output, right? Letter pause 2 of encrypted. Yes, that's perfect. Okay. Alright, and then as I said, you need to increment your pause on every iteration of the major loop, and you need
So it will be pause, yeah.
Yeah. It'll be inside the repeat. Leave it up one, yeah, that's right. And then you need to length of sentence, yeah, that's right. Okay, but you also need to have a second repeat to iterate through your encrypted or clear text as well.
Okay, so that will go in there.
No, it'll go just below your first repeat there.
So it won't include this stuff, or will it?
Yes, that's right, yeah.
Okay, and then the other stuff will go in.
Yeah, so you need your pause just underneath that, and you need your pause 2 where you are now, yeah.
Okay, so we'll change pause 2 by, yeah.
Yeah. Okay, but pause 2 there and pause over there. You just need to swap them around. Okay, and then your length of clear text, not encrypted text, sentence. Okay, that should work. Now you just need to do the opposite for decryption.
What's that sentence that uses all the letters in the alphabet? Lazy fox jumps over the...
Oh, yes, but I would not suggest you type something so ambitious in. Start off with one word, because you're going to have to remember what the output is to decode it. I got this right. get that right. Okay, decrypt. Input. See.
The first two letters on my side last time. But that's all I did.
Oh, okay.
And pos 2 somehow got to 325.
Oh.
So
Well, you do better than me. I only got one letter out, so I need to see what I've
what's
done
your
wrong
pos
as
2
well.
sitting on? It looks like 100 and something. Yes.
105. There we go. That's a bit
Yeah,
long.
I think that's part of the problem.
Okay. So I think there's an initialization problem here as well. So this pos 2 must be set to 1 inside here. So for every letter that we do, we need to set pos 2 back to 1. So pos 2 must be set back to 1. Over there. Okay, let's see if that made a difference. Would help if I
I got quite a couple of
letters out.
but then
So I got HZMW.
what will it put for a space? Because mine doesn't put a space out.
Yeah, mine works.
Oh no.
Yes, you're gonna have to add space in. So just put a space anywhere. Okay, and let's see what happens with the space. Encode Bob space Bob. XK. Whoops, that was too slow for me. Let's try this for 5 seconds. Oh, I just keep on forgetting to do it the right way. That's the other thing you'll learn. People don't read when they use computers.
So input something that had 4 letters and then outputted something that had 5.
That's impressive. That's impressive.
Can't even try them. Yeah.
Okay, so set your output to nothing, set sentence to nothing, encrypted.
Is position 1 maybe not supposed to be 0 or something?
No, you need to start. Oh, you haven't. Yeah, you haven't reset your position 2. See, you have to reset your position 2 for every time you do your outer loop.
That's the one that I did here.
So you've initialized it up there and you did it at the bottom. I would try moving your set position 2 up to there.
Yeah.
Yeah. Okay, see what happens. Didn't work. Or did you still get 5 letters?
No, I only got 2 letters.
Oh, even better.
We moved position 2.
Okay.
I think where it was working.
Alright.
It was.
Okay, so if I want to equals encode, then repeat length of sentence. Okay, for clear text. Intervals of sentence equals intervals to repeat length. Let Change files by 1. Yeah, that should work. It's not working.
Well, I'm still getting 5 letters. I'm getting the same 5 letters, which is good, which is a good thing. But
Okay, but they're different letters. It's not A.
well, I always get the same letters out.
Doesn't matter what you type in.
No, if I type the same thing
If
in,
you
I
type
get
the
the
same
things
thing
out.
in, yes, that is a good sign.
Okay, wait, let's try and type in ABC. Oh, is that a Q? Q.
Is it matching what you
There's
got
an F
here?
in there somewhere.
Okay.
Something's ABC. NOB. N-O-B. Let's try and see.
You're not typing anything.
There we go.
Working.
Okay, so let's try it all again. So I'd probably set everything off by 1.
Yeah.
One little mistake.
Yep. Welcome to programming.
Oh yeah, completely different answer now. It's all characters.
Oh.
Yeah. Okay, let's see if I put a sentence in it, puts the space in, because that's probably the best way to see. Okay.
What would the best way to make sure that your decoded or encoded text has spaces in the same spot as your original? So like this example that we had here, see it's got spaces. How do you think you would do that?
I'm not sure what you're talking about.
So where did you...
To align the outputs underneath each other.
Yeah, kind of. So where did you put your space? Have you put space in here
At the end.
for both of them? So then yours is working correctly. So if you map the original character to the same character, then you'll end up with the same output. So as long as your spaces are in the same position, they will appear in the same position on the output. So mine doesn't do that. I put my space over there and over there.
Okay.
So if I type in the sun is...
It's asking if you want to encode it.
Yes, I keep on forgetting. The sun is hot. You'll see mine doesn't look like the sun is hot. Let's change it up a bit. So this is a little bit better because now you don't know how the words are made up. Whereas in this example, you can see how the words are made up. Okay, so how are you going to change yours to handle decoding as well? You've got all the code there, you just need to change a few things around.
We just need stuff to use to it. No. Yeah. And I need to put different variables in. If. Is there an undo button?
No. Actually, I think there is. I thought there was.
Okay, no, never mind. Of sentence.
Yeah,
yes.
so under delete, under edit.
This needs to change to encrypted. Change to clear text. Is that it?
And then there's one more thing. technically you don't need to do it, but length of encrypted text. Okay, they are one-to-one, so they will have the same length, but technically you should loop like that. Yeah.
Let's try put the same thing. Is that OVITEQ?
Yeah, try. Yeah, you can try that.
Sure, that's not what it said. I know. You can. You can see the first one, sure, if you can.
Is that
I
right?
think that was what I entered.
Yeah, could be. Okay, so you're an encryption master now. Okay, was it that difficult
Not
in
that
hindsight?
difficult.
Not so bad, eh?
Yeah.
You just got to think about it a bit,
Yeah.
figure out what pieces you need, and then put them together in the
Yeah.
right order. Okay. So
And I'm sure that all comes with experience.
yes.
Yeah.
Okay. So this is the fancy schmancy version where we create our own custom blocks and make it really easy. And if you have a look, that was the whole program. So that plus that, using our custom blocks, achieves the same thing that we did. Okay, so we have got about 10 minutes left.
Oh, I'm needed for my dad. My time will switch me.
Oh, okay.
Because I think I told him 4. Which
Oh,
was
no, 4's fine, we can
no,
carry
no,
on.
no, no.
Okay.
Have you seen the new Microsoft Surface Studio?
Yes, I have. Are you going to buy me one?
Oh, totes. Sure.
They're not that expensive.
Aren't they?
They only start at $3,000.
Oh, that's actually not so bad. Yeah, it's not so bad.
Yeah, I would love one.
Yeah.
I would love one. Okay, so loops. We've used them before, so you're familiar with them. We're just going to go over them formally now. Okay. So the first one is what we call a counter-controlled or definite loop. Definite because we know how many times it's going to happen. And the way that works is you have a repeat and you put a number in there and that says go for 10 or 20 or whatever value you put in. The second one is a condition controlled loop, okay, or indefinite loop. Condition because we say repeat until a certain condition is met, and by met I mean it's true. Okay, so is number of bullets equal to or greater than 0, then carry on repeating the loop, that kind of stuff. And that condition may never be met, so the condition may carry on forever and a day. And the last one is called the forever loop, okay, or infinite loop. That one carries on forever until you stop it. And you've seen now we've used a stop command to get it to stop. You also have seen in previous exercises we used the forever loop wherever we were doing something on the screen, because we need to check forever to see if we need to update stuff. Okay. Traditional programming, Scratch quite a bit, not most modern programming languages. Most modern programming languages use what they call event-based programming, but certainly all the programming languages from yesteryear used a forever loop as the main loop in their program to get everything to run. Incidentally, do you know what the screen thing is on the right?
It's like a bolt or something.
Okay, it's called a Mobius strip.
Yeah.
Do you know what a Mobius strip is? Okay, a Mobius strip is named after a mathematician called Mobius, and it's basically a piece of paper. You twist the one end and you glue the ends back together. By doing that one simple thing, you've changed something which has two surfaces, the front and the back, into something that has one surface. So if you go and do that Go take a piece of paper, put one twist in, sellotape the ends together. Then put your pencil down on the paper and pull the paper. So it's drawing a line. You will see you'll draw a line on both sides of the paper without lifting the pencil up. If you cut along that line, you will end up with a big circle. It won't break into two circles.
Okay.
I know you don't believe me, that's why I'm telling you to go try it at home. Okay, but that's a good example of something that's infinite. Okay, so here's our exercise to do our times tables, which you said you didn't know. So you can get the computer to do them for you. Okay, you're going to write a program that asks for the times table you want to practice. So the 3 or the 4 or the 10 or the 5 million, if you want to do that. Then your program is going to say, not spoken, but by writing it on the screen using the say or think command, the times table you chose from 1 to 12. So 1 times 3 is 3, 2 times 3 is 6, and so on. Okay, so having just gone through our loops, we're obviously going to use the repeat loop because we want to do a 12 for each one. And then we're going to use our join blocks to get our numbers into a little sentence. And then we're going to use some maths, obviously, to do the multiplication to get the answer. Go.
Oh, so it's going to repeat all of them.
Yeah,
Okay.
so you will say, what times table do you want to do? I want to do the 3 times table. Then it will basically loop through 12 times and do each of the 3 times table. So if I can see if I can beat you this time. So,
We're doing it up to 12.
yep. Where did you get stuck? Oh, description 12, set pos equal to 1. Okay. You need to put your set pos equal to 1 outside your loop.
Okay.
Otherwise it gets set to 1 every time the loop runs. So
Oh,
only do
okay.
your 1 times table.
There we go.
and
Okay,
answer
now
equals
it's right.
pass. Okay, so you got the answer, but you need to do the fancy schmancy,
This
make
needs
it
to
look
be
pretty.
like, mm, mm. Mm. 13 pounds now. We started at 2 times.
Yeah. You could have also just moved your change bar to the bottom.
Okay.
Give it the same result. Okay, cool. Well done. Is your dad on his way? Should we carry
He is
on?
on his way. So,
Okay, let's see what was next. Okay, so that's what we did. You managed quite well. Okay, so let's go through something else quickly. So we have what we have a condition controlled or indefinite loop. Okay, so we have a test condition, repeat until test condition. Okay, if it's false, it skips everything inside and goes back to the top. Okay, if it's true, it does everything inside. Okay,
so it will only, the program will only start if the test condition is true. Will only continue doing everything else after.
yes. Yeah, so if it's
Okay.
false, it gets stuck in the loop.
Okay.
When it hits true, then it carries on with the next command. Okay, so what happens if the test condition is always false?
And it will only ever do what's inside the loop.
Yeah, so the program will effectively get stuck there. If it's true, it'll always skip over what's inside and carry on with the next command. Okay. Alright, so next exercise, we can start this. We'll see how far you get. Okay, so we're going to do an addition test. Okay, we're going to write a program which picks two random numbers between 1 and 50 and then asks you what their sum is. So, for example, what is 34 plus 56? The answer would be 90. Okay. You then need to enter the answer for the sum. If you are right, the program must end. If you are wrong, the program must ask you for the answer of another sum. So it carries on, asks you for sums.
Oh, so you need to pick the answer.
Yes. So it picks two random numbers, says what's the answer. If you get it wrong, it'll carry on asking you for that. If you get it right, it'll pick two new numbers and carry on. So it's never going to stop. Okay, it'll carry on asking you the answer until you get it right. When you get it right, your reward is another sum. Okay. And
Okay.
so your first thing, you're going to need two variables. So for the two parts of your sum, you can call them A and B, X and Y, whatever floats your boat. And you're obviously going to use the random command to pick those values between 1 and 50. And then you're going to need an answer, which will be the sum of those two. And you have to ask the user for their answer and compare it and see if they're right.
Right, I'm going to need an answer variable.
I wouldn't call it answer though, because we already have a built-in one called answer. You can use it, I don't think Scratch will complain. Maybe just call it ANS instead, so that you know that it's yours and not the built-in answer or something else.
Okay. You can't put these numbers in here, or you can using the...
You can using the join. You've got an aversion to the when green flag click block.
Yeah. If answer equals sum, equals sum. I'll just go like repeat those steps all over.
Yeah.
Can you?
That's what you're going to have to do. You're going to have to duplicate them and put them back in the loop.
I just
The thing is, you have to set them up once.
Okay.
Yeah. So you have to set them up once, and then you also have to use them every time the user gets the answer right.
Yes. 45 to 52.
Yeah.
Okay.
What happens if they get it wrong? You're going to still carry on asking them new questions.
Yeah.
So
I need to do another if then.
Or you can use if then else.
Yeah.
Yeah. Not really there.
Yeah, I need to get something else.
Yeah. Okay, remember we've just done a block called the repeat until.
Okay.
So we want to use that block, so we repeat it until they get the answer right.
Okay, so then you put that here.
Yeah, where you do your answer check. So instead of doing the if then, you're going to do your answer check.
So it's here.
Yeah.
Right there.
Well, yes. Okay, let's use some cheating here. Okay. So we've used pass test as a flag to see if they pass the test. We repeat until the test is passed equals true. Okay, we have our two numbers, number 1 and 2, which you've done. Then we ask them what the answer is, which is what you've done. If number 1 plus number 2 equals answer, then we set pass test equal to true. Okay.
So I needed a pass test function.
Yeah, well, the variable to store whether or not they got the answer right. Yeah. Bad.
Yeah, easier.
Alright, so we'll carry on with this one the next lesson.
Okay.
Okay. Alright, let's just end that here.